Going to finish our discussion of energy here, just talking about efficiency. Now, some energy is lost as heat and sound energy each time a ball bounces for existence, but not just happens when a ball bounces, it actually happens in all processes. If this wasn't the case, the ball would keep bouncing forever. You may have heard of the idea of a perpetual motion machine. And that's what that ball would be. It would just bounce on forever. And that's because all its gravitational potential energy would be converted to kinetic energy, and the ball would bounce back up with exactly the same amount of total energy all the time. What happens in reality is that sound and heat are given off in the process. And that means that the ball doesn't bounce up quite as high the first time as it did the second time. Sorry, the second time as it did the first time. The efficiency of an energy conversion is a measure of how much useful energy is produced. So this can be expressed as efficiency equals useful energy divided by total energy, and all of that, so you would actually put a big bracket around that, times that by 100. Okay, let's give us a little example of that. I'll just go to the next slide. Okay, over a 100-kilometre trip, a car transformed 400 megajoules of energy from the fuel. The amount of energy that went directly into the forward motion of the car was 80 megajoules. So what was the efficiency of the car? So just turn the clip off here very quickly. Have a go at working out what you think that efficiency was, and we'll come back and check your answer. Okay, so you should have got that efficiency equaled, now the amount of useful energy was the 80 megajoules. That was energy that went into doing something useful, like moving the car. The total amount of energy is the 400 megajoules. That's actually the potential energy that's in the fuel. That's the chemical potential energy in the fuel. And we're going to multiply that by 100. And we'll get in the end that actually comes to about 20%, which is a pretty standard sort of number for motor vehicles. You see 80% of that energy, that potential energy that's in that car, in that fuel, is lost in the sense of 320 megajoules, which doesn't go into doing anything useful in the car. And when we mean useful, and we sort of in the most obvious sense of being useful, and that's going into actually moving the car. Now, you've got heaters and things like that, and radios and all sorts of things that are powered from your alternator and stuff like that. And so there's a little bit we haven't taken into account there, because that's useful as well. But the main usefulness of the energy is measured in actually moving the car, because that's what a car primarily does. So 80% is actually lost to friction, heat, all these other places. So only 20% of that potential energy, chemical potential energy that's in the fuel, actually goes to doing something that we want the car to do. And as we said, that's always the same in a roller coaster, which we're going to look at roller coasters soon. They run on this principle of kinetic energy being converted to potential energy and back into kinetic energy all the time, losing a bit of friction, losing a bit of energy due to friction and sound all the time. So the transformation is never 100% efficient. Okay, that does our discussion of energy. We've got these 4 YouTube clips here for you to have a look at. So just if you have got any questions, go back or come and ask me.